Hello, greetings to everyone. Uh, this is Dr. Elangovan, and I am a professor in the Department of Aerospace Engineering from SNS College of Technology. This is a part of the computer-aided aircraft drawing course, and then this videos is a series of lectures. And today we are going to cover something related to the dimensioning. We will understand the purpose of dimensioning, how it is being done, what are the different types of dimensioning, and all the sets of rules and convention that is behind it. Okay, so what is dimensioning? Okay, so to construct any object to its size, okay, I can generally make it 1:1 kind of a drawing and then give somebody, but then every time that somebody has to come and then measure it and find out. So in a drawing, if somebody do not want to measure and find out the dimensions, we can directly pull out the dimension lines and then put a text there, or a dimension text there, and then with a note or a symbol or whatever it is, and then say that this is the dimension. So to read the size of a drawing of a feature or in a drawing, we use dimensions, indicating on a drawing the sizes of the objects and other essential details like numerals, symbol, notes, etc. is called dimensioning. Now we can even use it for manufacturing purposes, where in order to manufacturing the particular part, we have to have the dimension drawing. Now, what are the elements of dimensioning? The elements of dimensioning is the dimension line, the projection line or the extension line, the leader line, okay, which will just try and pull out as to this is what is that indicated one for which I am giving the size, the origin indication from where the dimensions are being measured, then uh, sim- and the dimension itself. Okay, so this is the elements of dimensioning. You see the part. The part is a rectangular component and which has got a hole in it in the center. So we have the leader line. You have the surface finish symbol here. The arrowhead is drawn here on a dimension line. Bounded by the dimension line is the is a extension line, and you have the dimension figure, and either you can have a small gap or you need not have a gap here. Now here they have said there is no gap, but in generally in CAD drawing, in order to distinguish between the main component and the dimension line, there is a small gap that will be given. Okay, so next is the dimension line itself. In the dimension line, we have it's a measurement between two ends. The going Let me go back. Okay, so it's a measurement between two ends. A dimension line is continuous thin line. The two ends of the arrow, I can have an arrow or an oblique stroke. It is drawn parallel to the edge of the surface that is placed outside, and within the boundaries, we put a dimension line and then write down a text there. Now here we have written that we have put a diameter symbol. That means that this one is not a square slot, but it is a circular component, circular mm, a cylindrical component, and that cylindrical component, the diameter of the cylindrical component is 50 mm diameter. So placing of the dimension could be an aligned system and a unidirectional system. Different kinds of systems are being used in throughout the world. So it is up to us to understand for which company are we working for, and then based on their practices that we may have to do. Some follow first angle projection, some follow third angle projection. In India, right now, we are following the first angle projection, and the dimensions are aligned systems is there, unidirectional systems are there. And how we are placing the dimensions is what is the differences, and we are going to look at that now. Okay. So the projection of the extension line goes like this, drawn without leaving a gap from the outline. That's what we said. It is drawn perpendicular to the outline edge, which is to be dimensions. It is drawn obliquely, but parallel to the to each other. The projection line should extend slightly beyond the dimension line, just to show that it is a dimension. Otherwise, we'll tend to take it as an edge there. Now, it's a yeah. And so this is the extension line. And suppose if it is a taper, and then I put a line, and then take a projection line, and then show that at the dimension at this point of the taper, this is what is the dimension. Okay. Next, we'll move on to the construction line. The construction lines are sometimes required to move beyond the boundaries. Beyond the boundary, for example, if there's a keyway or some kind of a slot that has been there, before the chamfering of the slot, the material must be like this. It must have been an extended. Now, these are the construction lines, and then you have a point of insertion. So, at the time of manufacture, one has to, before the chamfering operation being done, one will check for the distance between, will maintain the distance between this point and this point, the point of intersection, and that is the dimensioned point. And once that is done, then the chamfer will be done as a subsequent operation. So this is the construction line is a continuous thin line, and let's move on. Okay, then we have the arrowheads. The arrowheads are shown here. Arrowheads are used to terminate the dimension line, and this is the dimension line, and this is how it has to be drawn. Students must take pains um, to draw the arrowheads properly. It could be an open arrowhead or a closed arrowhead, or you can have an arrowhead which is filled up. Generally, the included angle of the point of the arrow is 15 degrees, and the length of the arrowhead 1 is to 3 times. If the width is 1, then the length must be approximately 3 times. Okay, so the arrowhead terminations are terminated by placing like this. Either you can put the arrow like this, or in between, you have a very small slot, you cannot draw an arrow, you can just put only the lines, but they are bounded by the two arrows of the next dimension. Arrowhead termination, this is what it is. Okay. The next one is the oblique strokes and dots. We have when a small number or a very small number of dimension lie on one adjacent to each other. If they are very nearby, then instead of putting arrow, it will look very clumsy. So you can put a small tick mark there, and the tick marks are very small, and then they pass through the intersection point there. And it is one way, or you can put some dots also. Dot will now, drawing dots is going to take time, but then a tick will be a much oblique strokes will be a much simpler and a easier one to do it. Now, the next one is the leader or the pointer lines. They are being used. Are thin point lines are being used. Now this is what it is. Now you have the all the dimensions are here. Now this is not an edge, but this is a surface. So this face is to be uh, to be plated, or this face is the the datum that has to be taken. So such kind of writings can be done on this. So for that you use a leader line. A leader line has a text there, and then it also has just one open-ended um, arrow. The other side it is open. The one side it shows as the arrow. Or you can have these balloons there. If I there's a here now this part is part number one, and this part is part number two, and that is what it clearly tells us. The next one is the lines, leader lines for repeated dimensions. Now there are some kind of dimensions where there are holes are there, and these are all repeated there. So you need not write for every hole what is the dimension. So I just mark on one and then say that 3 holes of dia 6. That is what I can write down here. So one can really understand that these 3 holes are of one type. These 3 holes B is of dia 6, and these 3 holes are A, and they are dia 12. That can be understood very clearly. So here also the dimensions are there for the fillet, and if I make like this, it's going to be very cluttered, and so we can simply say typically all are 10 radius, we can say for in general. So wherever it is not mentioned, you can take up the typical dimension, and if it is mentioned, then you have to go for that particular dimension there. The dimension figures are if it is a symmetrical this one, we can write like this. From the center line we can try and pull out. Symmetrical steps are being given here. Okay, so whatever is given here is a diameter 160, diameter 200, diameter 240, etc., like that. Okay, so this is another way of dimensioning. The last one is the very sheet that we have said. The different sizes of the sheets are here, and A0 is the biggest drawing paper, and half of this is the A1, and half of the A1 is A2, half of A2 is A3, half of A3 is A4, and half of A4 is A5, and each one will get halved on the alternative sides. Okay, so this is the dimension of the size of the sheets. Okay, so we will meet again on next phase of this video. Thank you very much, and I know that this has been a long video, but thanks for being with me. Thank you very much.